So I want to make this quick video. I hope you can hear me okay. Find the real solutions of the equation. So in this one here it says round your answers to the nearest hundredth. Has 2 decimal places. I would have to take the 4th root of both sides. But because of that, because I'm taking the 4th root of solving, anytime I take the even root, I need to consider the positive and negative. So when I add 3 to both sides, I would get positive 3 plus or minus the 4th root of 26 into 2 decimal places. When I go here and I do the 4th root here, what was it, 26? So I round that to 2.26. This is supposed to be a 3, sorry. So 3 plus 2.26 would give me 5.26. And 3 minus 2.26, which would give me 0.74. Those would be my 2x values. So remember, anytime you're solving by taking an even root, you need to consider positive and negative possibilities. Using the properties of radicals to simplify this expression. So, I have the 4th root of 48 over the 4th root of 3. So since they're both 4th roots, I can divide. They get the 4th root of 48 over 3. And if I'm not mistaken, 48 over 3 is actually 16. And 4th root 16 is actually 2 to the 4th. So the 4th root of 16 and 4th root of 2 to the 4th would just be 2. You could have done 4th root of 16 in your calculator there to see that. This one was a little tricky, put it in simplest form. So I have 4 over, and then I have this difference, which includes the square root. So in this case, to simplify, I always use my conjugates. So the conjugate of 3 minus root 5 is 3 plus root 5. So I'll distribute. So remember, this is, since it's minus and plus, it'll just give me a difference of squares. It's helpful, I can show you really quick. I multiply these out, I get 9 minus, plus 3 root 5 minus 3 root 5 minus 5. These cancel, so I just get 9 minus 5. So 12 plus 4 root 5 over 4. Oh, is this the answer you had? That was quite good, but look, 12 and 4 and 4, they're both divisible by 4. 12 over 4 is 3, 4 over 4 is 1, so it could just be 3 plus root 5. So that was just a simplification question. Step at the end. Alright, let's switch to green. Okay, so here I've got, write this expression in simplest form. The 5th root of 486, a to the 5th, b to the 6th, c to the 10th. Okay, well, right away, this is Keenan sleeping here on me. Right away I see a to the 5th. Well, the 5th root of that is just a. C to the 10th, the 5th root of that is just c squared. And then what I need to think about is, well, what if my 5th root 2 to the 5th is 32, I believe. 3 to the 5th would be 3, 9, 27, 81, 243. Ooh, I think that's the one that's a perfect 5th factor. Because 486 is just 243 times 2. So I've already actually took the a and the c squared out by taking those 5th roots. So what do I have left here? Well, b to the 6th, I could break that up to b to the 5th times b. So watch what now happens. Let me erase this over here so it's not confusing. Let me write this. This equals this. Okay, so now the 5th root of 243 is indeed 3. So I'll get 3a. 5th root of b to the 5th is just b. So I still got my ac squared. Now all I'm left underneath my 5th root would be 2 and a b there. So basically I'm just looking, well, what is my highest, like if it's already a factor of 5, the power you just divide. If you have like a 486 or b to the 6th, how could you break it up to see if you have a perfect 5th power? Like this is b to the 5th times b. This is 243 times 2. So this would be my simplified, simplest form. Okay, next, simplify this expression. So whenever they give you one like this, sometimes the hint is this. Like this, we may be able to simplify down to the cube root of 4, because then we could hopefully subtract. So let's see. 256 over 4 is actually, let's see, 256 divided by 4 is indeed 64. 64 is actually 4 cubed, so check it out. 3 cube root of 64 times 4 minus 5 times the cube root of 4. Watch what happens. Well, we could take the cube root of 64, which is 4. So I get 3 times 4, that comes out of the cube, times the cube root of 4, minus 5 times the cube root of 4. So I would just get 12 cube root of 4 minus, because 3 times 4 is 12, minus 5 times the cube root of 4, which is just 7 times the cube root of 4. I can just subtract, because now they're like roots. Okay, let the graph of g be a translation 4 units down, followed by a reflection in the x-axis of the graph of f of x equals the cube root. Okay, so first the cube root of x minus 2. So this is my original function. So first it's saying g of x is first a translation 4 units down. So I subtract 4 from the whole function, and then a reflection in the x-axis, so that's a vertical reflection. So then I'll multiply everything by a negative, so it'll be negative f of x, and then this switch signs to plus 4. So let's do that. So g of x, if I plug in f of x into this, I would get negative cube root of x minus 2 plus 4. I see this answer here, put the plus 4, but because we're doing the shift down first and then the reflection, it reflects the shift down up also. Okay, ooh, these ones are tricky. Square both sides, but this is the type where, you okay, Keenan? This is the type where I have to square both sides. But this I square with this being like a whole term, so it gives me x minus 5 plus 4 x minus 5 root of 4. So it's basically just like my a plus b squared algorithm, but then when I square this side, I just get x plus 3. Okay, then we go up here just for space. So let's check it out. This, if I combine, it becomes x minus 1 negative 5 plus that 4. Okay. Oh, this is nice because when I subtract x from both sides, those will go away. Add the 1 over, I'll get 4. Divide both sides by 4, I just get root x minus 5 equals 1. Square both sides, x minus 5 still equals 1. So x would equal 6. I guess I should check my answer. So go back here. 6 minus 5 is 1 plus 2 is 3. Square root of 9 is 3 also. So it'd have to be 6. That looks good. Find the radius of a right cylinder with a volume. On your answer to it, and a height of 2. So the right cylinder, volume of a cylinder is equal to the area of the base times the height. And the base is a circle, so it'll be pi r squared h. So we know the volume is 225. Let me do it over here for the height is 2. Okay, so I could divide by 2 pi. So r would equal 225 over 2 pi. I haven't taken the square root of that, so it says round to the nearest hundredth. Let's go to my calculator. Where's the pi? I don't see it. Is that it right there? Okay. So for the hundredth, it'll be 18.80. And feet, right? So the radius would be 18.80 feet. Select each function that represents a vertical or horizontal stretch of the graph. Ooh, interesting. Well, Well, the thing is, this one, when you take the square root of x squared, this just becomes 9x. So this is not a transformation of the x squared graph, it's a totally different function. But the square root of this would give me 9x squared, so yes, that one does work. And this would give me the fourth root of 81, which is 3x squared. So they're both just vertical stretches of the original graph. So that's why this one doesn't work. It's not even the same function family, because that's a linear function. Alright, so let's look at this last one before I have to make a second video, because I'm running out of time on my plan. So, consider f of x as negative 5x squared. G of x is 2x to the third. Determine whether the domain of the product is the same as the domain of f. Well, looking at these, they actually, neither of them are square roots. They both have a domain of all real numbers. We could plug in any x value and have an output. There's nothing divided by x. So the product would also have the domain. So this should be the same, the domain of the product, because they have the same domain, all real numbers in both functions. Okay, I'm going to go make part 2 video. Keen is doing a good job sleeping here.